Well, hi, good morning, and thank you so much for joining me in my shop here. Today is October 19th, another cool day outside to start, but getting all the way up into the 20s, yeah, 20. It's going to get up to 20 today, which is pretty warm, which is pretty nice. Sunny, sunny, sunny. Wonderful nights for doing astronomy, except that big honking moon is up there. So I've been trying to do astronomy in the evenings, but the moon is really interfering. Otherwise the sky would be just fantastic, but not happening. So, well, I'm talking about not happening. What about this radio? So at the end of the video, the last video, the first video, this radio was howling away from what sounds like two resonant of an IF, or somehow the output of the IF is getting back to the input side and coming through again and setting up an oscillation. It's a curious thing in that in itself you can't hear it directly. It's not a modulated oscillation. The detector can't detect anything, and so it kind of can exist without you really realizing it. And as you tune stations in, there's a heterodyne tone that starts at a high pitch and comes down to 0 when the station is tuned right in, and then as you tune past the tune point, the tone returns. And I think that's a strong indication that there's a free-running oscillation in the IF. Another indicator of that is the kind of sound the radio is making. When you tune in a station, say someone's talking, instead of sounding kind of like what I sound like now, it sounds more like this. A bit of a sound like this. Not that the bandwidth has been collapsed, but that there's a there's a word for it and I'm going to forget it now. A situation where you're close to resonance, and those frequencies which are at the resonant can kind of ring in the circuit and maybe last a few more extra cycles. A little like a bell. When you strike it, it vibrates for a period of time and stops. So when you strike the IF with a this doesn't make 100% sense, does it? Because if the IF is oscillating at the IF frequency, who cares if you're presenting it with some audio information, audio frequency information, which really isn't happening. You're really presenting it with a similar frequency in the IF. Did that make any sense? Made a little bit of sense to me anyway. So what to do about it? So I think the first thing to do is investigate and find out a little more about this situation. Is it really, is it real? Or is it because the radio's out like this? Or what's going on here? And maybe even a peek at the schematic to look for where the particular capacitor is that should be stopping this effect, or controlling this effect. Maybe that's the best place to start. We'll start right at the schematic here. So one of the circuits to look at in a radio like this is the screen circuit. Not all tubes will have screens, like this one does not have a screen element in it. This one does, and this one has two. So why don't we look at how the voltage is derived for the screen. So if we pick this one here, we go up and it's just connected right to the plate supply. In some receivers of these models, T1, on some receivers, these models is inductively tuned. No, that means they got slugs in the coils, but no, mine has capacitors here. So and the screen over here, you see the two of them are connected together, and then they go the same thing. Well, I'm not surprised, because I'm not surprised this radio has a howl in it. Most of these radios have a separate screen supply line, if you like, and there's a big fat capacitor on the supply line. You can't put a big fat capacitor on this line because it's also working the plates. The screen here has no No capacitor to ground. Well, I think that makes it really susceptible to exactly the problem we've got. That's what I think. Huh. A little bit surprised about that. I'd be surprised the radio can even operate like this. I don't think I've ever seen this quite done this way. There isn't even a resistor in here. There's nothing. Okay, well, if that's the situation. There's no big. Is there any big fat capacitor anywhere in here? Is there any? I saw one in the radio that looked like a 0.1 anyway. Well, we might hunt them all down. It's probably this one I saw. Okay. So the big fat capacitor, I would call this one the big fat capacitor. It's not that fat. It's the same as this one here. So this is the capacitor that's going to the chassis here. There's nothing big and fat about it, but then the physical size doesn't really reflect the capacitance that well. So almost certainly the guys put the right one in here. Now this one's not involved with this tone we're talking about. I'm just spotting something I should have spotted a while ago, which is, you know, how is the chassis connected. Interesting. I think about this a little bit. Let's just take a peek in the book here. The book. This is one of the books for sure. So here we have this is just a typical IF amplifier circuit. And if you look at the screen connection, you see it comes to a resistor, then to B plus at the bottom there, and there's a capacitor on it. That's typical. That is typically how you do it. Well, they've just gone and hooked the wire up to the B plus and forsaken the capacitor, which is, I think is a big problem. How do you handle this situation here? The only thing that comes to mind is detuning the IF, trying to reduce the Q on the IF and maybe broaden it a bit, because in order to make the radio less likely to oscillate. I don't know. That's interesting. Coffee time. So here's my idea. I'm going to use the SDR with a pickup coil to try to pick up this, let's call it phantom signal, phantom oscillation in the IF of the radio. Get it visible on the SDR, and then fiddle with the alignment, with the adjustment of the IF, and try to see if I can kind of knock it out. Or knock it down, I guess, to the point where it doesn't matter. It's not loud enough to be a concern. I don't know, that's the best I can come up with. When I started on the radio, the IF was tuned way off. Maybe there's a reason for that. So, and as for knowing that it's gone, so the SDR may show something and then fiddle and something's no longer there. Knowing that it's gone would be picking up a station, tuning it in, and not hearing the heterodyne. I think that's you know, that's proof positive too. So that's the approach I want to take. So SDR. Let's get the SDR. Okay, I'm going to stop the video. I'll get everything set up, and we'll do this. Okay, so I've already encountered something odd, and I haven't even turned this on or done anything with the radio. All I've done, and what have I done? I've connected this simple loop here on the end of this cable onto the antenna into my SDR radio here. And there's already a 455 signal sitting there. Where from? I don't know. Let's look at it together and see what the heck is going on here. So I have the radio, the SDR, tuned to 455. That puts the red line right on 455 over here. You can see there's a signal there. Let's just zoom in on it. And so it looks very much like a signal with two sidebands sitting there. That's not good. We don't want 455 signals floating around my house. Where could this be coming from? Let's listen to it and see what it sounds like. Sounds like nothing. Even though we see sidebands here. Well, what if I stretch this all the way out? So these sidebands are, let's see, this is 455, 465. So this is like 15,000 hertz between here and here, which is probably why we're not hearing anything. 15,000 is a little high. Or maybe it's not. Maybe these are not sidebands, they're just things. What would be doing this? I don't know. Okay, let's stop for a second here. Okay, so you can still hear the, I'll turn the sound off here. It's just a hiss anyway, we don't really need to hear it. So there's the signal, here's the coil. Let me disconnect right from the radio here. My gosh, so I don't have an antenna connected. I've never seen this signal before. It's right in the key spot here. So I'm going to kind of reboot my SDR radio. We'll see what happens here. That means I'm going to have to reinitialize the software too. Okay, play. Same stuff, exactly the same thing. I'm pretty sure the SDR has nothing to do with this frequency, 455. Let me take the wire right off. Yeah. Nothing happened at all. I'm defeated already. Is there some chance that there's a setting wrong in my SDR? Direct sampling Q branch. Seems fine. Everything seems fine. Well, coffee. I go drink some coffee. What am I supposed to do about this? Okay, thinking about this just a little more, there is another possible cause for the trouble in this radio, and it could be these long clip leads I've got hanging out here. So I made these connections so I could use this meter over here for doing the alignment. And these wires hanging out may be sufficient to enable this oscillation. I don't know. So I'm not going to be using the meter. We're going to be relying on the SDR. We're going to be looking for additional frequency in here. I'm going to tune the radio, fool around, we'll see what happens. Currently I'm connected, so I have an outdoor antenna connected to this booster loop, if you like, or a transmitting loop, you could call it that. And then the actual antenna sitting here for this radio. Okay, so we turn it on. And I've got nothing hooked up to my SDR here. Wait a minute. That's not going to work out. Now I actually have the loop hooked up. Really didn't make any difference on the SDR, did it? Something's not right. Something is not right. Just a wee bit of variation in the SDR there. Okay, it seems to be working. Okay, that radio volume is down, but the radio's switched on. It's plugged in. There we go. First, we'll try to duplicate the issue that was present at the end of yesterday's session. Then I'm going to remove these clip leads and see if that doesn't resolve it right then and there. Oh, I kind of just jumped on there, didn't it? That's kind of odd. Okay. Horrifying oscillation. I don't hear any horrifying oscillation, but I sure see something right in the middle of the... Now we're listening to this radio. We're not listening to the SDR. Oh, that's another station coming through. Hey, radio's working really good. What happened to that funny oscillation? I thought it was terribly annoying. You can see something tuned through there. And you can hear it. Here's something else. It's kind of a neat way to tune a radio, by the way. Now this is quite distinct. There we are. Okay, so I'm going to disconnect some leads here. No difference. No difference. Okay. So we know whatever's going on, assuming there is something going on. It's not from those test leads. Let's put this. So this is one of the IF coils right here. I'm pretty sure we can go right on there and get a blaster of a view. So what's that weird thing that just popped out to the left? Like there's that steady signal at 455. Now what's that thing just to the left? So it looks like what's happening is the radio sensitivity is coming up because the AVC is relaxing. And when it comes up, it brings up that second peak there right next to the 455. So as you bring in a station, even way out here, it starts activating the AVC or creating an AVC voltage, and that lessens that other signal. Then as soon as the AVC relaxes again and the radio sensitivity goes up, but I don't hear it, the noise is not going up and down. Well, I guess it is. There's something else sneaking in from the left side there. That's just some noise signal, I guess, in my shop. Burlington is a city in Ontario.
That's not the roles you guys have to worry about. You need to know your role and pick up the phone and call me.
This guy's receiving really well. Well, what's the problem? Is there a problem? What is that thing? So we know that thing is there no matter what. No matter what I do, no matter even if I disconnect the antenna from the SDR. So those things, which have to just SDR stuff, leave it at that, even though I've never seen it before, right at 455. And there is some interfering signal in my house right near 455, like around 452 or something. I don't see it here though. Okay, well I'm chasing a problem that doesn't appear to be there. That's kind of silly. Is there really a problem with this radio? We should put it on, take a look at the dial accuracy, put the cabinet back on, run it for real. Maybe there's nothing here at all. Maybe. Okay, let's try tuning in a few stations here, and we'll be able to check how accurate the dial is. I'm just going to do it with real radio stations rather than a signal generator, and we should be down at this end. Now there's an like the radio is not completely in the cabinet, so there's a huge parallax thing going on here, so you got to be a little careful about doing this. So we can start by looking for the French station, which should be right around here. So I have the booster loop, but it's just a little distance from the radio right now. You can see it's just laying back here. So I'm just going to flip it up against the antenna.
Getting older could be the key to unlocking a new level of contentment in life. A new survey commissioned by Home Equity Bank suggests Canadian homeowners aged 75 and older are out.
So this is the French station here. The French station is broadcasting at 865, but in this radio it's being picked up at like 990. It's way off. So this is really does need a shot at alignment. The alignment instructions for this. I'll have to take a look. I'm going to take a look here. I'm going to stop and just read the instructions myself here. Okay, so we're listening to the French station. What I'm going to do is I'm going to tune to where the French station should be, which by my reckoning would be right about here. Okay, and then we're going to try to leave it tuned there. Pull these knobs off. So we should be hearing the French station here. That's my thinking. And so I can make the oscillator adjustment without using a signal generator. We just look for that French station. Here we go. There it is. Boy, you'd think I'd done this before. So we know it's correct now at 865, and we'll do the antenna boost here. That's a lot. Okay, so now we're going to tune down some stations here.
For it to get slow from about Islington Express and Collector, so you're approaching the 427.
That'll be 680. Let's go further. It's going to be 640. Looking for the sports channel here. That must have been it. Yeah, they're talking sports here. So this is 590. I can't tune a radio. Okay, let's put this on. Oh, I got a lot stronger there right at the end, just from the cabinet and the speaker. So I'm looking to make sure these are in the center. This is in the center, the cabinet's in the right position. Let's take a look at where we're tuned. So it should be 590, right on the money, 590. Excellent. That's it. That's the alignment.
They're just simply a very average football team. And yes, you're right. If they weren't the Dallas Cowboys, but I probably wouldn't even be talking about them in a bye week.
Very good. Okay, I think all I got to do is just put the cabinet, put it back together, put some screws in, put the knobs on. We'll check it out again. Okay, last test. I put it in a darkened room here so we could see the excitement of the panel light. Here we go. If you notice, the panel light does something very similar to the dim bulb in terms of how it comes on. Bright at first and then dull down, and then it'll brighten up as the radio comes to life. I hope. There, you see, it's brightening up. Well, that squeal is back. Come on, I put all the screws in. No, it's definitely there. Well, come on. I thought it was all done. Why now?
Yeah, so Mavidi, unfortunately, if you were terminated in 2016 and it's been more than 2 years, there's not much we can do about it. It's been
So this is,
timed out.
let me just line this up. This is 640 we're listening to.
I think this is just something that...
GVP, the ramp to Don Mills remains closed. It's slow from Don Mills to York Mills.
No, it's not really squealing now.
There's a sign, something...
If you can get it tuned right on, of course the squeal is nulled out. So perhaps it's a problem that's not a problem. There's the 860. 860. Looks pretty good. Now there's no, I don't hear any heterodyne up here. There's a stronger station up around 1430. It's a good antenna. The radio's hooked up to a good antenna. And this booster coil here, I'm holding it right up against the back of the radio. So, well, takes a bit of careful tuning. You can kind of tune this. Wow, I don't know what to think.
On the show today, on the Zoomer show today, and she said I could get a free home run book. And so you can call us at 1-877-728-2447 to get your free book today.
A lot of parallax
just
in that.
visit our website, use the phone number there.
Over 100,000 spectators from around the world.
Here's a good strong station.
The marathon goes tomorrow. There are extensive road closures.
Nobody would complain about
events,
that.
including some specific ones right now for the 5K.
There we get it.
So absolutely, yeah. So there is no, I mean, no one should be working.
I mean, I hear the narrow bandwidth in the tuning, but where's the tone now? You know what? I think it's something external down here. Again, you can tune it out. What's happening is the interfering frequency is now so low the radio can't produce it, the speaker can't produce it, you can't hear it. Probably still there.
The regular season to the point where they underachieve in the playoffs.
It's kind of a classic radio sound, isn't it? That tuning sound. Well, I'm going to leave it as it is because I think it's good enough, and I don't know what's causing it. And we saw that there's nothing protecting the screen circuits. So then this is just the way it works. So I will claim. Very good though. I think that's good. Radio operates well. Somebody else took care of the problems of getting rid of all the old capacitors and whatnot. Good show. Well, thanks a lot for watching, and hope you enjoyed that. I have to have something else in here next. Wonder what that'll be. See ya.